Hello everybody and welcome back to the channel. Today we're taking a look at the Warlark 80mm quadcopter, and this one is got its obvious similarities to other inducted based copters, but this one has 7mm motors and it has a camera built down in here, and it's got a flight control board with an OSD inside. But well, let's get to the specifications after we look at how it flies. But be sure to come back because I have 2 bits of information that are going to be very important for your flying experience.
Going for our first flight, and we can already see that the lights in the house are kind of blowing out the camera, and the lights of the windows is also, there was one of those bumps right there. I was never able to solve that. I think it must be a motor issue. It just kind of, it almost acts like it hits something, but it makes flying kind of tough actually, because you kind of respond with your eyes, you know, you see something and your fingers try to respond to it to correct it. But it took me a while to get used to that, so I wasn't changing my course all of a sudden when those things would happen. But it flies pretty well, you know. When you get in real even lighting, the camera works fine, but when you get any sort of extra light in the area where it looks at a light bulb or it gets some extra sunlight, it just blows it out. And in some of the cases you'll see in here in the house, especially around the front door, when I descend the stairs, it's almost impossible to fly it. I shouldn't say that. It's very difficult to fly it when you have that much light being blown out in your view. And as far as SPV goes, that's really important. If you can't see, it's really hard to fly. So I think that's something they've got to correct right away. I'm going to bring the music up, and then after the flight we'll come back to the desk and we'll cover those 2 important things and the rest of the vehicle as well.
Okay, so the first thing, I told you I was going to get right to it. The first thing that I wanted to bring to your attention is that if you flash any other software, Clean Flight, Blade of Flight, anything else that comes up to this board, it will automatically flip to the right on throttle up. If you go really low on the throttle, it might not be immediate, but you'll get to a point on throttle and it'll just flip over real fast. The second thing I wanted to share is how to correct that. If you go into the CLI and you type set align underscore gyro equals CW0, hit enter, type save, hit enter, double check to make that CW0 is there, then also type set align underscore ACC equals CW0, and 0 is the number, it's not the word spelled out for the number. Save that as well, then you should be all set. When I got my vehicle, it was flipping automatically, so I had to sort that out. Solo Pro from RC Groups, thank you very much for dumping that CLI, and I was able to do a diff check on it and figure out what was different and kind of sort through all the different variables to find that out. So if you flash to Betaflight or anything else, it's going to zero that out to default. If you change from, it comes with CleanFlight 1.13. If you change to CleanFlight of any other version and then go back, it's not going to matter. That setting is custom to this thing. I don't know what CW0 does. If you know, please drop that in the comments below. But that is going to be critical to flying this thing. Okay, let's get on with the rest of the specifications. Mine came with a canopy, and XY Motor from RC Group said that there was only one canopy available and it was 3D printed. But if this thing is 3D printed, it is the best 3D printing. I'm not a 3D printer, but if this thing is 3D printed... Oh, I did crack it. Is that a crack? Yeah, it's a crack. But this thing has been through a lot of crashes. And let me scoot over here a little bit and I'll roll some footage up there. So I cracked the canopy. That must have been on one of my last few flights because I didn't notice that before I started cutting this video tonight. But this held up well, and I think it'll still hold up a lot. I fly, as you saw from the flight footage, of a mixture of over carpets and hardwoods, and actually over cement too when I come back here in the shop area. And I've crashed in all of them, and I haven't tried to treat this thing nicely by any stretch. Just fly, have fun. And then we've got the frame here, and I've also got a snappage right there. See right there? But it's still holding together just fine. But this thing, it was probably still running over there. I've crashed this thing so much, and it was very difficult to get it in a flying state. The PIDs that it come with, I think, are the defaults, and it's just unflyable. So we're going to jump into that, and the PIDs I have, I'm not going to claim them to be the best, but they'll get you what you see. Also, batteries. Let me grab the batteries. These are the batteries I flew. And this one doesn't fit, so that one's out. And this one fits, but it sags really bad. I actually get brownouts with this one. If I fly pretty steady for, I think it's about 20 or 30 seconds, it will just drop out of the air because the voltage gets too low to power the receiver. So this one only works in short bursts. This one works fairly well, but it's not the best. I've had this one for a while. These are Hubsan replacements. There's a good look at the back of it if you want to match that online. I think you can find these fairly reasonably priced, probably in packs of 4 or 5. This works reasonably well. I find that these batteries don't quite center down here like I would want them to. Let me see if I can get this one shoved in here again. You'll watch how I do this. So now we kind of have to manipulate it down and get it. We want it up in there. So you can see that we get most of the weight right in the center, or it does affect our flight characteristics. And you notice that also pushed the camera forward, the camera mount just slightly forward. This used to have tape on it, so I could pull out by the tape. I know, don't pull out by your battery leads. I know. But my tape I apparently pulled it off. But as you can see, this is a tight fit. It will come in and out. I've done it a whole bunch of times. Maybe that's why my frame's broken. There we go. This one fits a little bit easier, but that really doesn't matter because it doesn't fly very well with that because it just sags too quickly. This one fits in nicely, I think. It gets just under that lip and almost works as a grip. It centers the battery over the center of the copter, and it provides enough punch. It has the kind of the amount of weight to that you want to be towing around. So this is the only battery that I can recommend at this time. And I usually don't recommend Hobby King batteries, but Nanotech, and it's a 260 mAh, and then you can see right there they've marketed it as rated for 35 to 70C. So that's what we have, and you can see here on the top plate we've got our VTX and OSD combo. It's got pins that go right down in there, And one of the things that I did when I was having troubles with the flipping on mine is I flopped the motors around. So you see that, let me get a pointer. These motor wires used to be looped around this piece, so they were much neater. I took them all out. I did loop this one, but then I didn't think it was worth it. So these wires were actually a little bit neater before I rewired all the motors, and I did that because of the flipping issue, which turned out weren't related at all to these motors. And I also ordered some other 7mm motors because, as you saw from the flight video, there's, I don't know really even how to describe it. There's an odd catch to where the back end will kind of jump up or possibly down, or it will kick and go down. But you saw it doesn't happen that much, but it happens from time to time. I think it's probably something specific with my unit. Hopefully it's not spread across a bunch of different units. We have the UFL antenna here. Let's take the VTX off. Now let me work that off. I always want to be really careful with that. I don't want to get those pins. So I'll come back to that. Okay, I had to work the VTX off. I wanted to be careful because I didn't want any of these pins getting bent. And as you can see here, it's got those tiny little pins that connect down to the board. Right here, and it's got that UFL connector, and you can see where this might have a heat shield. I think that's probably where they would put it, and if you've been flying this, especially in back-to-back flights or so, this area will be pretty warm, so be careful about putting your finger on there. With this UFL connector, we can of course get different antennas and try them out, but I found the reception be pretty decent. I can fly through all 3 levels of our house with a good enough signal in order to fly, so I think this works pretty well. Here's a closer look at the board. You can see that it's stamped F3 right here, if that'll focus for us. So this is the F3 version. And I don't really know if you were to place an order what you'll get for sure, because on the OverSky site it says F3 or F1, and they don't have like a button select one or the other if you wanted to do that. Maybe that'll clear up in time. On the Banggood website, they say these are F3. So, you know, I'm not quite sure how that all works. And then this button down here, that's if you were to need to short it in order to jump the boot pads, in order to flash a different version of firmware on there. And these lights are indicators of our VTX channels and also status. It's this light right down here that comes on when you've got power. And then I believe, you know, I've never actually seen it because I've always got the goggles on. I would suspect it either changes color or shifted to another light when we arm it, but I can't confirm that. You can see our USB port, and if we take a look at it from this area, it's really low to this back brace, and maybe that's how I got this little nick. And while we were away, I went ahead and just threw a little glue on there to cure that up. This little glue here. Didn't take hardly but a drop, held it together for 10 seconds, and bam, fixed. And let me show you my USB cable, because in order to calibrate the accelerometer, it gets to be a bit of a challenge. And this is a pretty flat USB cable, but I took my Dremel and I shaved down the bottom part in order to be able to get that in, and the board still stays flat. And speaking of the board and staying flat in crashes, sometimes you see these tiny little clips down here. There's 4 of them. Those hold the board down and hold the board flat, and you may have to press the board back down in on some crashes. I had to do it myself. So that's something to keep in mind if you have a crash, and then when you're able to take off again, as we often are with these ducks. That's a nice thing of having these on here. You can crash, and then you can just take off and fly again. You don't have to go retrieve the vehicle. If it flies, you know, wonky one way or another, it's probably because the board came loose. As far as the camera goes, let me unscrew the mount. You can see we've got a number of different positions that we can go to. I can't see any use for these back 2, but I suppose if you wanted to get up real high above your subject and you weren't really FPVing, maybe you're just wanting to do some experimenting of some sort, you could use those. And the camera will also, in crashes, sometimes shake loose and come dislodged. It's got those 2 tabs at the top that we'll take a look at as soon as I get this off. Okay, here we go. So, pretty simple little mount. Someone else could 3D print something else if you wanted to have it in a different position, or you wanted to have more notches in order to change your angle. And the camera, unfortunately, it's a bit proprietary. I'm not sure where we can get a camera that's got these cutouts or these extensions on here. And I think that's the first thing that they need to replace, is they need to get a different camera. This one is not good. As you saw in the video, it gets blown out by light. And I say this during the video, but I'll repeat it now in case someone didn't hear it or missed it. The flight video is on a normal, regular day. It's not necessarily particularly sunny. We have some open blinds, and I did turn on a number of lights, and it just gets blown out anytime it gets light in the lens. So I think this sensor needs to be something else, because it makes flight somewhat difficult. In certain circumstances, it makes it really tough. But this is the camera. A little closer look at it here. You could just try a regular board camera, but I don't think it's going to fit when I compare it to others. Others have a different PDB on it, and you have to be sure that the layout allows for this to be mounted in this mount, unless you're going to design your own. Let's get some measurements off of this. Got my blinking calipers out here. Please bear with me. And let's measure. Let's do our best to do a measurement here in the ducts. 35.4 thereabouts. And let's get a bite on these struts. These struts are vertical. They're not leaning like they are in the E101, which has got a number of other names to it now. 120 there. Let's see if we can do something to give you an idea of the distance of this cage down here that I reference a lot for battery sizes. Well, this will get close. It's about 34.25. And then our width, it's probably 20 millimeters. Thickness on our ducts, 8.57. Let's see if we can get a bite on the side of the duct here. Looks like it's about 1 mil. You, of course, could cut the cage off and put in different size batteries and use a rubber band to go from post to post. And I also think a rubber band going over the top might be handy, because the canopy does pop off a fair bit. Not a lot. One side will come loose and it'll end up kind of up, which can affect flight if you try to take back off, but it's not terrible. Let's also make sure we're still zeroed. Get a bite here. 0.86 around back. 0.77. Yeah. Let's check the distance from motor post to motor post. Make sure it's 80 millimeters as it is marketed. So yeah, pretty close. Maybe even a bit smaller. But I suspect they're probably right on the money there. I can't think that we would need... I guess if you wanted to design your own canopy, possibly there might be some designers out there that want to do their own canopy. So from these two bits, got about 42.89, so probably 43. And let's go from this bit up here. This won't be very accurate, I bet. Let me see. Because I have to lean the calipers, it's going to be kind of sketchy. 43.5. And it does look like this hollowed out strut is a bit thicker. Let's go from the bottom on that. So this one is probably the weakest of all the struts, but we have two other support lines going there, because it's been carved out to 6.6. We also have these little bumpers for our motors. Boy, that one might be a really estimate there. 1.1. And it's interesting to look at, they paid attention to their design detail, because you see it has this little outcropping here that helps to keep our motors from popping the end cap out. And if we look at the profile, we see that the nose of these props stick out, and that makes this canopy pretty important, because this actually helps to protect not only anything getting into and damaging our electronics there, but with the canopy on, it also protects the motors from taking a direct strike on the motor stems. Let me put the canopy back on, and I don't think I drew your attention to, but it does have a tiny little hole right here on the top, and that's where our antenna should go. At least to me, it seems like that's where it should go. And let's take a turn on the scales here, and then we'll do one last thing. We'll take a look at the VTX and how we change channels. Oh, batteries. I forgot to measure the batteries that I mentioned. Turn this back on. So we get 7.45 there. Here. 19.57. And then this is going to be a little bit wonky because you see I put some packing tape on mine to have to keep from pulling these out. Obviously I've been flying these batteries the most with this particular unit, but I'll squash that down and do what we can to get real close to that so you can 30.46. And then this battery, which does fit, you just have to finagle it in there a little bit. Let's measure the thickest part, which is down here at the end. You can see this is caught on the plastic. I could actually take that off and mark it in some other way so I know what that battery is. Let's go out like this. 831. Let's go this way, see if we can get the biggest part. 19.4. And then our length, which doesn't quite center in that motor cage area. Not motor cage, in the cage of the flight controller. 37.9. 38. So that gives you an idea of the two kind of batteries that will fit. I do recommend you find batteries like this. I made contact with mylipo.de to see if I could buy some other batteries that are like this. I really like mylipo batteries. I think they're some of the highest grade single cell batteries we can get. I haven't heard. I got an initial contact from them asking about what I wanted, and I followed that up, but I haven't heard back from them. But I do think that they said that they were going to be out of the office, so hopefully I'll hear from them and we can get some different batteries to try this in. So let's put it on the scale and let's weigh it. And we'll also give a few of its counterparts, little brothers, little sisters, a shot on the scale too. So I have two others I'm going to bring in here. We have the original tiny hoop with an FX798T and upgraded motors, but didn't upgrade the connector here on the back. This is I guess you'd call it a custom hoop. It's got an E101 frame, which that is cropping up in a bunch of different forms. I've actually got another one over here from the Furry Bee people. Pretty much identical, but I think this one might have stronger motors than the stock one. So I'm going to investigate that in a future video. And then also with another 798T. Scales ready, let's go. 29.45. The original whoop. I want to get that up here. 19.4. 21.2. And one of the big differences, I added a satellite spectrum, and this has also got a flight controller in there that I can program, and that's a lot of fun. So that's the weight of those, the weight of the batteries themselves. So let's start with battery numero uno. 7.7-ish. And the Hubsan replacement. 10.9. That gives you an idea of the different weights we're dealing with. Of course, it's not a direct comparison from one of these vehicles to the other, because this, again, is running 7mm motors, and this is running 6.5mm motors. And you can see I use loom bands on this one, and you could do something similar to this motor cage. You could cut these bits and then run a loom band on these little points that we have out here to keep the canopy on. You could do the same thing over the top.
Here we're going to take a look at the OSD, and you can see it reads the PIDs just fine, and you can make your changes right here, which is very handy. That's one of the primary features I use on OSDs is PID tuning, and then we jump into the RC tuning side of things. At any time there's something you want to take a longer look at, just pause the video. I made a few adjustments here. You might want to note some of these numbers. And I've turned off many of the options on screen. Some of the more traditional stuff that you see for the scrolling sidebars and the horizon. That's just, I felt it got in my way of seeing what I wanted to see to fly, so I turned those things off. Of course, there's lots of GPS stuff in here. It's a full-fledged OSD. and many of those things aren't going to be useful for us because those features just don't exist. And then we're back to the PIDs. All right, let's take a look at the flight controller firmware setup. Okay, we're all set up. Take a look at the configuration. Now, this is not stock. Because of the issue that I had with the flipping, I was changing different flight controller firmware around. I just stuck with Betaflight. This is 301. Now let's connect, and you can see that we have the SV Racing Evo target, and this is our accelerometer settings. We jump over here to ports. I have the DSM2, DSM-X version, so you may find that these selections are different depending upon your receiver. Configuration. If there's anything you'd like to see here, just pause the video to take a closer look. And this is probably the section of most value to you. I had to take a lot of flights to get a reasonable tune on this. And I use reasonable because I don't consider myself to be some sort of tuning guru. I leave that to other people, and oftentimes when I get comments about tuning, I give a general overview of kind of my approach, which I primarily get from Joshua Bardwell. So if you want to learn more about tuning, I highly encourage you to watch his videos. I consider him my reference, and I watch every one of his videos on tuning because I think that I learn a little something every time I watch his videos. You might find that these values vary depending upon your vehicle, but this should at least get you in the air, and you should be able to fly it reasonably well. I did turn the horizon strength down just a touch. Default is 50. I just like it to be a little bit softer than that. I don't have my radio on, but this is the channel map that I have selected, of course. I didn't use any deadband. And here I use switches for arming and for changing my flight modes. If I can get this to scroll down. So we've just got horizon and arm, no buzzer or beeper or anything like that. We drop down here to the CLI, verify the version, and then our status. Let's go back to the desk and let's take a look at how we change our channels and bands for the VTX.
Okay, we're ready to plug in a battery and show you how to change the frequency and band that your VTX is on. Now, I should note that on the OverSky website, it says the operation will be changed according to feedback from customers. So the instructions I'm giving you now in the next batch of runs may not be valid. I just need to throw that out there in case this ends up being different in future iterations. I'll take my battery and we'll plug her in. You can see I've got Warlark. I kept calling it a Warlock. Every time I would think about this thing, I'd call it a Warlock. So, hopefully you can see that. We've got lights in here in the front, and the LEDs are laid out in alphanumeric. So we've got this row, which goes by number, 1, 2, and 3, and then the most forward row goes A, B, and C. And depending upon which lights, and I'll put a link to the OverSky site where it shows the layout for what the frequency and channels the lights mean. But really, I mean, this works just fine. I kept thinking it was the button that would help us change the channel, but you're probably not going to be changing the channel on this very much. So you need to know how to do this at least once, and then if you have to go back and look it up for future flights because you're flying with friends or something, you know, that's just something we have to do. That's part of the hobby. So with the throttle in the lowest position, if we press the button, it'll flash. I'm going to try to keep my fingers out of the way. So it flashed twice up here. So LED flash, LED 3, which is the innermost back row as far as it's facing us here on the camera, flashed twice. That's an indicator that we are on 5865 because the front row did not flash. So that's zeros is according to their chart. And if we want to change that, we put the throttle at the mid position, and then we double press this button, and then we change the channels with this stick. I know I'm a little bit out of shot here, so I've done this before but not videoing it. So if I move the elevator we see that you see the light shift. Now we got 2 lights, 1 light. Now we go down. So now how do we change the frequency or the band that we're on? That'd be the next thing, right? Well, you do that by going left or right. So I'm going to go back to the channel that I had. So we've got now 1 red light over there. Now it's shifted to the middle. Now we've got the 2 innermost red lights, the outermost red light, the outermost and the innermost. Now the 2 outermost, all 3. And that's how you go through the band. The red lights indicate the band. The yellow or green lights represent the frequency. And that's how you change your channel free VTX. And I don't believe there's a save on this, except for to pull the throttle back down. And you can see it switched back to just status light, which is powered on. The last thing to cover here would be the motors themselves. How do they perform? They seem to perform reasonably well, but unfortunately I don't have any other motors to compare it to. I have some more motors on order. Actually ordered them because I thought I had a motor problem with the flipping. If we look at the OverSky website, it lists these motors as being 48,000 RPM. What does that mean? I think it's just like anything else with these hobby. These motors will get you in the air, but I can't tell you whether they're better than any other 7mm motors on the market. I think we're probably just going to have to buy some and try, and I will definitely be doing that at least with one particular brand of 7mm motors, and I can report back. I'll note it down in the description below of what I found for flying performance. I have a bunch of 6.5mm motors and 8mm motors, but I don't have a group of 7mm motors. I think we've covered it pretty well. If you have any questions or comments, please leave those in the section down below. If there's anything else that you want to know about this, please leave that as well. If you like the copter and you like the video, give the video a thumbs up. Thank you for watching, and I'll leave you with some more flight footage.